Hi, I'm Cheryl Leach. In this problem, we're asked to find the area of the unbounded region that I'm showing on the graph. Well, let's take a look at this. It's bounded above by the function minus 7 divided by the quantity x minus 1 cubed. Notice that there's no left-hand boundary to it. However, we are stopping on the right-hand side at -1. Well, we know that you can calculate area under a curve by using a definite integral. But let's see what our definite integral is going to look like this time. So our area is going to be equal to the integral from -infinity to -1. And the function that we'll be integrating is minus 7 divided by the quantity x minus 1 to the third power, dx. Okay, when I look at this integral, I notice it's an improper integral. The lower bound is minus infinity. So I'm going to need to do this by using a limit. Because I don't want to plug -infinity in, I'm going to replace that with some value that I can plug in. So I'll be going from b to -1. And then, after I complete the integration, I want to let that value b approach -infinity. So that means I need to take the limit as b goes to -infinity. All right, now that I have my improper integral set up, let's go ahead and evaluate my integral. Now, if you need to do a little side work here to evaluate the integral, that's fine, because this is going to require more than just our basic integration rules. So let's go ahead and look at simply the integral of minus 7 all over x minus 1 cubed dx. Let's do a u substitution. I'm going to let u equal the inside of my composition function, which in this case, I'm going to try x minus 1. And when I do that, du is equal to dx. Well, that's nice because when I rewrite this, I can rewrite it as minus 7 all over u cubed du. And then this can be rewritten as a minus 7 u to the minus 3 du, and I can use basic rules. So I'll pull out the minus 7, and then I'm going to add 1 to the exponent, so that makes it u to the minus second power all over minus 2, plus my constant of integration. Okay, a little more simplifying here. -7 over -2, I can write that as a positive 7/2, and I can also pull that u down into the denominator. So I'll have 7 all over 2u squared plus my constant. Oh, one last thing. We need to get our x's back. So I'm going to have 7 all over 2 times the quantity x minus 1 squared plus my constant. Now I'm ready to use this information in my definite integral. So I still have the limit as b approaches minus infinity. This integral is going to be 7 divided by 2 times the quantity x minus 1 squared. So I'll just replace this with 7 divided by 2 times the quantity x minus 1 squared. And again, I don't need to worry about my constant of integration because this time I'm doing a definite integral, and I'll be evaluating this from b to minus 1. So now I need to plug in my upper limit and then subtract what happens when I plug in my lower limit. So I have the limit as b approaches -infinity, and I'm going to have 7 divided by 2. Now when I plug a -1 in here, I'm going to have a -2 squared, which is 4. Then I'll subtract what happens when I plug the b in. So I'll have minus 7 all over 2 times the quantity b minus 1 squared. Okay, a little simplifying here, and I've got the limit as b approaches -infinity of 7/8 minus 7 divided by 2 times the quantity b minus 1 squared. Okay, let's see what happens now when b approaches -infinity. Well, 7/8 has nothing to do with b, so it still is going to stay right at 7/8. Well, as b is getting very, very small, I subtract 1. It's getting even smaller. Then I'm going to square it. What happens when you square a negative number? It's going to become positive, right? So b minus 1 squared will be a very large positive number. Multiplying it by 2, again, a very large number. Well, then what do? I take 7 divided by this very large number. Think of 7 divided by 10 million. What kind of number is that? It's very close to 0. So this term is approaching 0 when b is approaching negative infinity. So overall, what happens? My whole expression is going to 7/8 minus 0, which is 7/8. So this time my improper interval converged, and it converged to 7/8. And that's going to represent the area under that unbounded curve. Thanks, I hope that helped.